Greetings from Engineers Without Borders at the University of Wisconsin Milwaukee. I'm Jared.
And I'm Ashley.
And we are engineering students from the University of Wisconsin Milwaukee. We will be telling you who Engineers Without Borders is and why we need your help.
Engineers Without Borders is a nonprofit humanitarian organization established to partner with developing communities worldwide in order to improve their quality of life. This partnership involves the implementation of sustainable engineering projects while involving and training internationally responsible engineers and engineering students.
At the University of Wisconsin Milwaukee, students in Engineers Without Borders have the opportunity to participate in projects such as steel and concrete bridges, water filtration and supply systems, computer setup and training, and solar power systems.
To familiarize yourselves with what we do, we will inform you of our most recent project to La Libertad, Guatemala, as shown on the map.
In various times between 2007 and 2009, our travel teams took a break from their normal lives and traveled to La Libertad to construct a sustainable water system. In 2007 and 2009, our data collection team tested water, surveyed the land, and performed health assessments on the natives. We found unsafe levels of E. coli in their water supply. We also taught the natives the importance of washing your hands.
Our project consisted of a spring box in which water from a river flowed into. The water flowed through PVC piping to a distribution tank as shown on the slide. The distribution tank also filtered the water. By using hydraulic pressure, the water was then directed into the homes of the villagers as seen on the top schematic diagram.
Shown on the right is our hydraulic pressure diagram. As we surveyed the land, we took GPS coordinates to map the terrain and find and record its elevation.
This slide just shows the chlorination process. Listed on the right are the advantages to using this process: no electricity, minimal training, and very low maintenance.
This slide breaks down the costs of our previous trip and will be very similar to our next trip. We need thousands of feet of PVC pipe, miscellaneous connectors, cement blocks, chlorine, mentors, and translation. Shown below is our expenses for materials, logistics, airfare for 8, and salaries, which are mostly for contractors down there.
Here's a slide for trenching and pipe layout. On the top right, you can see just a small portion of the PVC pipe needed on our trip. On the bottom left, you can see the pipes being placed in the ground. Another picture also shows some Guatemalan kids playing with our wheelbarrow.
We took what expertise our professors taught us and put it to work. We were able to improve upon what the Guatemalans thought the best route for their water would be. Keep in mind that we needed to get water from a river 2,000 meters away with no electricity. Here's a GPS map showing the village of La Libertad.
We are going to run you through a few quick slides showing different phases of our construction process.
This slide shows us creating hand controls to control the flow of the water. It also shows a large group of villagers who were excited to help. Here are a few slides showing the construction of the distribution tank.
And this is a picture of our chlorinator. This is a picture of the chlorinated water filling the distribution tank, getting ready to go to the natives.
When the project was finished, 330 people were with clean, safe drinking water.
During the last trip of 2009, we sent a design team to survey land by the small villages of Villa and Vihostich. This is our project for 2010 and 2011.
We surveyed the land to predict the best place to get water and run the piping.
We also collected water and tested it for bacteria. Here is a map showing the villages of Villa and Vihostich and where they will get their water from.
To keep peace between the villages, each village uses a particular water source.
To allow for this, we must use 9,200 meters of PVC piping.
We will create new spring boxes and distribution tanks for each village.
These diagrams are of the hydraulic gradients for Vitos Tiche and Bielom trace. The goal is to keep the blue points below the purple line. The blue points depict the elevation of the land. The purple line is the hydraulic water flow through our piping. When we encountered points above the purple line, we were forced to route the water around the tall elevation that we encountered.
We are now ready to start the next process of our construction. This is where we need your help.
As students, we can create safer and more sustainable water systems for villages like these and others around the world with the help of contributions from people like you.
Thank you for taking the time to listen to our presentation.
Thank you.